Something that I think is a little confusing is the idea of conservative and non-conservative forces in the mathematical sense. Hopefully it makes sense to you in the intuitive sense that if our change in energy depends on the path we take between any 2 points, then we have a non-conservative force. You can think about this in terms of gravity. If I move a ball from one height to another, no matter how I move that ball from the first height to the second, the change in the ball's potential energy depends only on the change in height. So gravity is a conservative force. Here's a force law that I've written down, and I want to know, is this force law conservative or non-conservative? So the way I need to do this to check is to integrate over 2 different paths. So first of all, we're going to go from the origin to point P in my diagram over here. And I'm going to do this one way, and I'm going to leave it to you to do another way, but I'll tell you the answer in advance so that you can check yourself. Okay, so I'm going to integrate this force law, and I'm going to go from the origin to point P. And if I'm integrating along a distance, I'm going to get a potential out. So the basic integral from my potential would look like this. I'm going to integrate along path A, starting from x equals 0 and y equals 0, to my point. And notice I have a dot product here. Oh, and I left off a negative, so potential is the negative integral f dot dr. In Cartesian coordinates, our dr would look like dx I hat plus dy j hat. And I'm only doing this in 2 dimensions, and it's an equal sign there. So look at my force, look at my dr, and you should be able to tell what the dot product is. And if you do that dot product and then write the integral, it's a little messy. Take a second to look at it. My limits are x equals y equals 0. I could just say x equals 0, y equals 0 either way. Integrated to x equals y equals L. And then when I do the dot product, I get these 2 terms. I'm going to switch to a new page. If you want to write anything down, do that now. Notice, though, along this path, it's true that y equals x. So our integral can be even simpler. And I think I actually left off my leading negative on that last line of the last slide, so I apologize for that. It's just potential is negative the integral of the force. And so now my integral looks like this, if I go from the origin to point P along that path. And this integral is not very scary. It turns out to be negative L squared over 2 times 1 plus L. Alright, so I told you that I'm going to leave one part for you to do. If you integrate along a path, I've labeled B, which goes in x and then in y, you should get a different answer. Now notice you'll need to integrate this one part, and you'll need to integrate this other part to get your total path length. So try that, and know that you should get a different answer than I did, and from that we will conclude that our force is non-conservative because the potential is path-dependent. And if you have a force whose potential is path-dependent, it is non-conservative. That's just what we mean by a non-conservative force.